Okay, welcome everybody. My name is McCowan, and this is obviously Intro to 3D Printing and Design. This was done by request. So I set up this presentation as overall introduction to 3D printing as well as design. The specific request was to focus on design, so I'm going to try to do that with this presentation, to do more design than some of the introduction to 3D printing. However, I did put it in here just so you guys get to the mix of what printing is and how it works and that type of stuff. So, welcome to the 3D world, right? So, now is the time where you can think of something and it can come out on the printer minutes later. This is an awesome time we're living in, right? So, these are some of the things that I recently printed. I brought some here that you can look at just to get your touchy-feely on them and see how it works. This is obviously my MakerBot 2 that's sitting right here in front of you. You know, a couple other things. Here's a Raspberry Pi case that I printed out. This little sweet thing. Here's the Pi case again. A screw, a little spring thing, and a couple other things that I've designed myself. So here's 3D printers. There's tons of them. 3D printers are rapidly being developed. There's been an explosion of printers and printer designs. This is just a few of them. There was hundreds more printers that I didn't pull into this because I ran out of space. All sorts of them, you know, with all different capabilities, all different price points. There's a couple in here, I think, that are professional ones that are in the $24,000 to $30,000 range. And then there's also this guy down here. This is the Medusa that I'll talk about a little bit later. He's in about the $500 range. So 3D printers, how does it work? 3D printing is an additive process. It takes raw material, lays it down layer by layer to build an object. It's distinctly different. As you can see, it's distinctly different from a subtractive process, such as like a CNC router or a CNC milling machine that you have a block and you subtract material away from it to produce your object. So it's an additive process. You can see here it's laying down layers, layer by layer, after it splits the image up, the object up into individual layers. It builds it layer by layer to make a three-dimensional object. So there's a couple of other technologies that are related to 3D printing that I thought I'd throw on here just to get you an idea of all-encompassing of what 3D printing can do. One of the big things is, so this type of printer, like I have in front of you here, it's a fused deposition modeling. It's basically, I take material and I lay it down layer by layer and fuse it all together into one. There's a couple other ones, stereolithography. That involves taking a tank of resin and using a laser to cure each layer layer by layer, building that up as an object. Again, it's still additive because it's doing layer by layer and it's adding material to the final object. So that's distinctly different from any other manufacturing process. It's an additive process, not a subtractive process. So printers, there's a huge variety of printers nowadays. Like I said, you can get down as low as $400 to $25,000, even higher. Some of the real production 3D printers that are for high-end manufacturing, they can get up into the hundreds of thousands of dollars. Printers that are capable of printing on in metal, those are the high-end ones. But down in the common range of what consumers can buy today, you're really talking about a range between, right around between $800 to to maybe $1,000 to $2,000 range. That's really the sweet spot for hobbyists. So that's about the price range that you can get. And I'll talk about two of the printers that are a big variety. They're good, viable options for today if you're interested in purchasing a printer today. But you can see, you can get from really tiny 10 by 10, and these are centimeters, 10 centimeters by 10 by 10, but you get up to 60, right? I mean, these are a wide variety, big range of what printers are. Notably, I mean, just recently, Staples said they're going to be selling a printer that's on the shelf. That's the progression of where 3D printers have gone today. Again, this is a fused filament fabrication. It's another for the additive process. That's just another name for how it layers down the individual filament to build it layer by layer to build your object. So some of the materials that it can print on, the common ones, are the ABS and the PLA. But there's lots of other materials that are rapidly being developed. One of the big ones right now is nylon. That's something that just recently came out open for consumers. Obviously, all these materials have their plus and minuses. Nylon tends to be a little bit stronger than the ABS or the PLA. On the next slide, next couple slides, you'll see I dive down into the difference between ABS and PLA. But those are the two common ones that most printers do today. Most common. But you can see other ones. You can print in silver, titanium, steel, wax, other polymers and copolymers, even chocolate and Play-Doh. I mean, it's an open source, very open source community with these printers, so you get this type of interesting and crazy things that people do, right? Printing with Play-Doh and stuff. So I did pull out, I ended up pulling out two printers for those people that would be interested in buying a printer today. Obviously I pulled out the Replicator 2, as you can see in front of here. I chose this one out of the hundreds of printers that are available. This one I chose because it's a consumer-ready product. You can go and order it. It's complete. It comes just as you see it right here. You put the filament in, you push the print button, and out comes an object. This printer does sell for $2,200. It's a little steep for some people, and this price is going to be dropping rapidly. On the previous slide, you saw that the one at Staples is going to be $1,200. Not quite as capable as what the Replicator 2 can do. This text is very fine down here, and you probably can't actually read it. I definitely can't read it there. But the specific thing is it's got very excellent resolution. So it's one of the finest resolutions of a consumer-ready printer that you can buy today. And that's specifically why I chose it. I chose it for two reasons. It is a consumer-ready product, so you're paying for someone to do the development of the software as well as the usage of the printer itself, versus being an open source product where you're waiting for the open community to do this research for you and fixing bugs and things like that. So if you're paying someone, they're more likely to fix it, basically. One thing to note here is that this printer only does PLA. It does not do ABS. The distinct difference between ABS and PLA, the reason why this one cannot do it, is you must have a heated bed to use ABS to print on. Otherwise, it just does not stick to the bed, and you just can't do it. So there's no printed bed, there's no ABS.
So you can use a piece of tape to try and get around that mixture.
Yeah, there's some ways to try to get around it. It's just very difficult. It's not impossible. It will come out, but whether it's worked or actually prints correctly or not, that's an open book. So the next one that I chose is a RepRap. So RepRap is a open source developed printing framework essentially. And the reason why I say framework is because there's tons and tons of variants of the RepRap. This MakerBot 2 was actually originally based on the RepRap platform. MakerBot themselves were part of the founders of the RepRap quite a while ago. They splintered off to make this product to actually sell it. So people are upset about that, but but this is one of a current variant of the RepRap. I chose this one is the Perusa Mendel. It's a good start. It's specifically designed to be easily sourced, as well as easily built, and to be easily used. There are other variants of the RepRap that have different goals, right? Some of them want to be much larger or scalable on their build platform. Some of them focus on being very affordable. Some of them focus on being very very reusable, I guess, or resilient, I guess. But this is a good one. You can look at the price here, $520. That's an approximate value. This is just for the part itself. You can see you save a lot of money because it is a 100% DIY printer. You buy the parts, you follow the plans that are on in the open source community, and you assemble it yourself. So you get the benefit of it's cheap, but you have to put it together. You don't get it like this, where you pull it out of the box and you push a button and you print. That just doesn't happen. You pull out the box and you spend maybe 40, 50 hours assembling it if you're lucky, and then you push the button and hopefully it prints. But again, you're saving a lot. You get your hands on. You get to play with it. You get to learn about it, and that's fun too. We're all in hackerspace, right? That's what we do. So let me talk a little bit about the difference between ABS and PLA. ABS, it pulls its primary attributes. It's strong, it's flexible, it's machinable. It holds up to higher temperatures. There's a couple drawbacks to it as well. It kind of has an odorous smell when you print with it. But then you compare it to PLA. PLA, you can, it's available in a wide range of translucencies. It has a glossy feel. It actually smells a little bit nice when you print with it. So, I'll print some more up here.
This is ABS.
So yeah, there's a sample of ABS here. I'll put it up here so you can compare the difference between the two, so you can feel it. But actually, yeah, I can attest to it. It does actually smell nice. And I use this printer in my office, and I don't think my wife would put up with me if I was printing ABS all day, because it does kind of smell. So one of the things is material cost. It's about $28 shipped on eBay right now. That's about the cheapest I could find it. The one thing to note is these prices are dropping rapidly. They are about 6 months ago, this price was $28 a kilogram. This was $58 a kilogram. So you can see it's a huge price drop. And not only that, and this is either one. This is about the same for ABS and PLA. It's about the same price. So one thing I want to point out is here's a nice website. If you go here, you can do a price comparison. They have a huge list of everybody that sells them. They'll tell you the price per kilogram. The one thing that you need to note is that the shipping costs do vary. If you go out there and look at the site specifically, make sure you choose the U.S. because right now the cheapest per kilogram is sold by the UK, but it costs about $30 to ship to the United States. So that's what. So that's why I make sure I put ship cost, because obviously you want it at your door and just pay. I got it really cheap for a kilogram, but it cost me $60 shipping. So another thing to note is watch for these prices to drop. I mean, they are dropping rapidly already just by themselves. But some new things coming out, like the fill extruder. It was a Kickstarter that just recently ended. I ended up getting one. It was about $300, it gives to me. And what you do is with the fill extruder is you buy the raw materials that they make the filament out of. You buy pellets of PLA, you put it into a hopper, and out comes the filament, right?
Does it use an auger?
It does use an auger and a heater. It heats it up at a specific rate and it extrudes it out. So with the fill extruder shipped, I can get the price down to about $11.40. You can see a huge savings from the $28.
How much volume is a kilogram?
So here's a kilogram. This is a kilogram of material. You can go quite a long time printing. It's with a kilogram of material. As a comparison, up here I have, this is 1 cubic inch of material with 100% infill, and this weighs about 28 grams. So you can compare how much material is here and how much is here, and you can get an idea based off of this about how much it's going to cost for the material when you print out some of these things. Now, just we'll get into it a little bit later when I tell you about printing, but this, just showing you this size, the volume of material that's in here varies greatly. You can print this with at 5% material, which means it's only 5% of the volume is filled with material. So you can see that it's much less dense than
the black ABS one is 10%. You can show them that.
So yeah, this is 10%. You can see on the back side of it, it's mostly hollow. There's nothing in there.
That's nothing in the middle.
And if you actually look at, you can really see it. Some of these things you can hold up to the light and you can see the hollowness of some of these parts. It's really green and it was extraordinarily hollow. But yeah, you can go down to as low as 5% material of volume. And that's something that's configurable when you actually go and print the actual material. One of the other things to look for when I'm talking about material is look for some changes in materials. New materials will be available. Like I said, one thing that's just coming out is nylon. High density polyethylene is starting to pick up as well. Some elastic plastics. It's just a rapid development of plastics that are coming out today. They all have different, different attributes. You can't say one is better than the other because it just depends on what you're looking for. If you're looking for strength, if you're looking for lightness, if you're looking for printability, if you're looking for flexibility, heat tolerance, all sorts of attributes. You just have to pick the right one. Right now, there's really only two mainstream ones, which is ABS and PLA. But some of these ones are coming online very quickly, and you get to choose the right one. Nylon will be the next one that comes online. I just purchased some myself. I have yet to print anything on it, so I can do that. So, free design software. I threw this up here. I know you can't read it probably. I just wanted to give the effect that there is a lot of free software out there. 3D printing is developing very rapidly. All of these applications, I would say that there's probably not one that is more than 2 or 3 years old. This is just a small list of them, and this list is growing by leaps and bounds every day. But the one thing I wanted to point out is that you don't have to have expensive software to get the job done as far as 3D design. Traditionally, 5 years ago, I would say that's completely opposite. There was a very small handful of 3D design software, and they cost thousands of dollars. AutoCAD, costs thousands of dollars, and those are the real high-end manufacturing. And the big thing about it is that you really just don't need that type of functionality, and that's why you see all these ones springing up. And specifically, Autodesk 123, they're the makers of AutoCAD. They still sell $1,000 software, $2,000 or $3,000 software for the manufacturers. But they also support the free version, which gets us, the community, into 3D design, and we are going to go get those jobs that they're going to need to pay the thousands of dollars to go and do design. So that's kind of the motive that they're looking for. So I threw this up here and I put this note at the very bottom. This is a great site. If you go out to the MakerBot website, they have an education site. They've given an introduction to quite a few of these. I've probably downloaded a good 10 to 15 of those to try them out. They're really all across the board. Some good, some bad, some terrible, some very hard to work with, some not so much. So if you want to save yourself some time, go out to this website and just take a look at their introduction to some of these software before you start downloading. It's just a lot of them are just a big old waste. So let's talk a little bit about 3D design. I just threw this in here because you really have to stop and think about, what am I going to design, right? What am I going to do? What am I trying to accomplish? Do I want to make something that looks cool? Do I have a specific functionality? Do I have a specific use? You can see most of the stuff that I focus on, it has a specific purpose. That's just what I do. I'm not really an artsy type of guy. You can see I have a case for my Raspberry Pi. I had a need to my Raspberry Pi, and you had something to put it in, so I made a case, right? I have a toothbrush holder, right? You put some double-sided tape, you put it on the back of your medicine cabinet, you stick a toothbrush in there, and you're good to go. I printed this for my mom. She bought 4 of these at $4 a piece and paid $2 shipping. This cost 17 cents in material to print, and maybe 25 minutes of design time. So it has a specific purpose. Obviously it's faster, it's great to pull actual objects off of my build platform. So all the stuff that I do generally has a purpose, right? I have a need for something and I go design it and I go and print it. That's not to say that's the only reason that you would design something, right? Art is a great, another one that I bring up, of course. Does it have a purpose? Really, to artists, I'm sure it has a purpose, right? So the other thing is, so once you think about what you're trying to do, the other thing is, has this been done before? Probably. Go out to the Thingiverse. There's, I think they just hit a milestone. I think they had their 250,000th upload or something of objects or something. I don't know what the number was. 100,000 object that was uploaded, and that doesn't include the customized ones. So that doesn't include the variants, right? So you upload one, someone pulls it down, modifies it, re-uploads it. That doesn't include those. Out of all the objects that I have up here, a lot of them are Thingiverse. Thingiverse here, Thingiverse here, Thingiverse here. I didn't design all these. Even the Pi case. Why would I redesign a Pi case? This is a very nice one. It fits great. I just go to the Thingiverse and out comes on my printer. Why would I spend the time doing that?
Maybe you want a different logo or font.
Yeah, sure. I mean, certainly you can, and that's kind of what I said here. Is saying you can download it from Thingiverse. Maybe it doesn't quite fit your needs. Maybe you want, instead of a raspberry on the font, you want to put your emblem or logo or whatever it is. Pull it down, modify it, and then please upload it again, because it's a shared environment, right? Nothing's free. Give your work back to the work back. About before you design is, do you want this to be technical or artistic? In the next couple slides, there is a very big distinction between technical and artistic. I'm going to show you two techniques for design. One of them is designing in 3 dimensions, which everybody thinks that's probably the way to go. But if you're doing technical, that's definitely not the way to go. and I'll show you the distinct differences. The other method is the extrusion type method, and I'll get into that in the next couple slides. So the other thing you need to think about is your limitations of a 3D printer. These are going to be printed. Just, if you were a sculptor as an artist, it doesn't necessarily need to be printed, right? You're designing something for stone or whatever. It doesn't have to come out in a printer. Well, this does have to come out in a printer. So one of the things you're going to have to think about is you're going to have to avoid overhangs. If you take a look at this Raspberry Pi case, the overhang would be considered, so if it was printed like this, you can't print the top. You can't print this whole object as one because it's hollow, right? So what you have to do is you have to think about it, you have to print it like this, the top and bottom, because when you do that, there's no overhangs, right? So you have to think about that type of thing, and that's what I kind of put here is you can't print overhang with some exceptions, right? You can put supports in, which basically the system will build up a support mechanism such that you can print very large overhangs. But that wastes material, and it's just generally something that you would avoid. But you would do something like this. You would split your part into multiple parts. For example, the top and the bottom, and that's perfect for like a pie case where you need a top and bottom to close it up into more. So think about the minimum resolutions and the accuracy of your printer. This comes into play, when you're doing technical design. When you print holes for screws or attachments, you have to understand how big the holes need to be such that when the plastic gets laid down, is it going to be big or small, bigger or smaller than what you screw size. You can, of course, always drill it out. Generally, that's what I do in that case. I'll print it close to the size and then resize it with the drill. So then think about also interlocking parts, whether you're going to glue it or not glue it. Support mechanisms where you do glue it, make sure you have a surface area for gluing. Those are the types of things you need to think of in advance before you start designing. All right, so now that you've thought about designing, let's get designing, right? So you're gonna have to go and find some software. I like free, right? You can't beat the price. I actually have downloaded a lot of those tools that I showed you in the last couple slides, and I found that Autodesk 123D design is a great tool. It's not perfect. For example, it does crash quite often, especially when you're not expecting it. But that can be easily remedied, right? You just save often. we all know that. Most software you have to do that anyway when you're doing design stuff. But specifically, Autodesk 123, it's easy to use. It's got a very simple interface. It's very, very feature-rich. You can do quite a lot of things. You can't do everything, but then there's other free tools that you can make up the difference in some of the things that you can do. It's free, right? The price is great, and it's also available on PC and Mac. And there is also an iPad version that's a much cut down, limited version, as well as an online version that you can do in a browser. Again, it's not as feature-rich as the download products. And I haven't used it. I haven't used the online one, but they just actually bought Tinkercad, I believe this, and I have used that one, and that one is a great product. So hopefully they supplement their current online product with the Tinkercad.
And also, last time I looked, Autodesk had 4 or 5 different products, not just the design. There is a couple of other ones. One of the interesting ones that I played around with a little bit is 123D Catch. You can take a series of pictures of an object, you upload it to them, and they send you back a 3D model of that object based on the pictures. It actually is quite cool.
there's some limitations. It's still a work in progress, I think. From what I've used it, you have to make sure that you're in focus, you have to make sure that you don't change your zoom and all sorts of different stuff. So there are some limitations. It does an okay job. For much larger structures and you take a lot of pictures, then it does work out. But ultimately, don't take my word for it, right? I chose Autodesk 123 because it fit my need. Your needs are going to be different. Go out and find free software. There is, I guarantee, a free product out there that will fit your need, no questions asked. You may have to get one or two software and combine them together to do everything, but there is a free software. There is free software that's going to do what you want to do. So I talked a little bit earlier about the different techniques of design. The first one I'm going to cover is drawing 3D objects. I don't personally find this particularly useful because I'm not really an artistic person. This is great for artistic design and drawing. It is working in 3 dimensions. That's where artists, do their thing in 3 dimensions, right? When they're doing 3D stuff, I guess, and it's painting, whatever. That's 2 dimensions stuff. It is a great technique for artists. It's designed in 3D, so you're thinking in 3D. A lot of people can, they want a 3D object and they want to design it in 3D. When it comes to something like a Raspberry Pi case, it's terrible. It's nearly impossible to design this Raspberry Pi case using 3D objects. And I'll show you how it was actually designed in the next part, which is the extrusion. So you can see some of the drawbacks is you can easily get into trouble when you think about printing out your objects when you design them in 3D, because you'll get a lot of overhangs. That's not to say that you can't get around them by slicing up your objects and reassembling with glue, but just you need to be aware specifically of that. The other thing I mentioned before, it's hard to impossible to draw precise dimensions, right? It is, you're drawing in 3 dimensions. It's a lot of measurements. If you want to actually try to line up 2 3-dimensional objects, it's a lot of measurements because you have to measure in all 3 dimensions, right? So if you want a relationship between 1 or 2 objects, you have to make 3 measurements, otherwise it's not going to be in the right place. If you use the other method, you only have to measure in 2 dimensions because it's using the 2-dimensional and extruding method. Again, I find this personally less useful. You guys have different needs. If you're an artist, this is the way to go. If you're not an artist, so sorry. So this is what I talk about when drawing in 3-dimensional shapes. They give you some canned shapes, Autodesk 123. You can see you got a cube, a sphere, a cylinder, a pyramid, and a torus. These are just ones you can just pull down. When you pull them onto the platform, you get a choice of the relevant dimensions for the actual objects when you place them down. Obviously, the cube is you only need 1 dimension, right? It's a cube. I think actually this cube is, it can be it's a box or a square. It's solid. That's not inside. But this, the sphere is you only have 1 dimension, right? You have the radius of the sphere. Obviously the height and diameter of this guy, just the diameter, just the height and that guy, and obviously. But anyway, you can play around with it and then get some of this object. So once you have the object in place, you can use these modifier tools. And this is something I just did real quick to show you an example of what I did. This started out as a cube. And what I did actually was a rectangular cube, but it was taller than it was wide. And you can use these modifiers to push and tweak and pull on the object to stretch it. And you can see what I did was I pulled it up and I shifted it over to make this kind of skewed off. And then up here I used the fillet fillet one to kind of round over the edge there. And then I use this guy over here, which is the shell, which actually made hollow. And then I cut it off so you can see the inside when it's hollow. I did this really quickly, just as an example. You're really just going to have to play with these tools to see how they work. That's basically what I do, is just play around with them to see how you can tweak and pull in 3 dimensions. Some of the other things you can do with 3D design, you can draw shapes and patterns. You can see this guy here, I kind of revolved it around a circle. You know, the cube over here, I just multiplied it by left and in this direction and multiplied it in that direction. And then down here is a sphere that kind of follows this line and draws multiple spheres on that line. Again, that's using the pattern here to get this effect.
Question? If you were, that little object there printed, would that be too much overhang on the bottom, or would it be like self-supporting?
This here, you might get away with it because it's a sphere. Anything that's a sphere. The major thing that you would have to deal with on printing this particular object is getting it to stick on the platform. There's very little surface area that's actually sitting on the platform. It's really, in a true vertic world, it is just this line that's sitting on it. It's very thin. We're having a very hard time getting it to actually stick. Yeah, there are other methods for getting around that. You can there's a checkbox on this particular printing software for the MakerBot. There's a checkbox to do rafting, which is it will lay down a layer of plastic first and then print on top of that, just so that the adhesion is much better. This plastic sticks to plastic much better than the print that sticks to the build plate. The other thing is, another checkbox is rafting, or supports, which it will print up material around the object, and it will actually print on those supports such that it doesn't, the printed material doesn't sag down onto the build plate. Strengths and weaknesses, right? I mean, it does get the print out, but you're wasting material. It takes longer to print. So those are some of the things that you need to think about. It may be worth it for you to be able to do that, but I generally avoid it just because right now, the material is pretty expensive.
Just a quick thought. Couldn't you just grind up your waste product and put it through your filament maker?
Soon. Currently, the fill extruder cannot do that. They haven't tested it. There are people doing it, but it's raw PLA only. There's a couple problems with that idea, and the reason why they haven't
go out of solution over time.
Right, exactly. So raw material is much different than extruded material versus printed material. The properties of the material itself changes every time you heat plastic. It loses some of its previous abilities and it gains other abilities not so desirable. And that's why you don't see recycled material used very often.
100% recycled.
Right, 100% recycled components. They can use it. You can go out and see the one common use of recycled material. When you go stick your soda bottle in the bin, it's probably not coming out as another soda bottle, but it's coming out as railroad ties. You see benches, those types of things, because when you reheat it, it loses all its nice properties, which are easily moldable into that soda bottle again. But then it gains other ones, like it becomes stronger, it becomes more brittle, in some cases, or more flexible in other cases. So it just changes properties. So. Okay, so here's a couple more tools that you can use when doing in 3D design. You can use this combine and subtract. You can see here I got a sphere and I put a pyramid on top. I combine these into one. Down here I had a cylinder that I took away from this cube, and I just basically subtracted the cylinder from the cube. Distinctly different from subtracting the other one, the cylinder, the cube from the cylinder. And it depends. This first button is when you select it is the first one is the source. The other one is what you want to take away, and then this drop down here determines whether you subtract it or combine it, and then how you do that. Here down here, it's not very great one, but basically I put an upside down cone or pyramid into this, and I subtract it from the cylinder. So here's the other method that I'm going to spend most of a much longer time on. This is the sketch extrusion method. And basically what this amounts to, I put this up here as an example. This on the screen is this box right here. My friend Alex in the back, he bought a RGB to VGA converter for his Macintosh. It came without a case, so he needed a case obviously to put it on, and here's a case that we did. This is one of the ones that was a failed print. I actually broke off the pieces that kind of come down and cover some holes down here. So I just brought it in, but he has a good one that actually he uses every day. So this is exactly what is on the screen right here. In a nutshell, basically what you do is you design it in 2 dimensions here as a base platform, and then you extrude it into the 3rd dimension, right? So you build all these features into this 2-dimensional shape, and then out comes these extrusions into this 3rd dimension. And you use these features that are laid out here in various different intervals to extrude them. They can extrude, here I've done just the corners. These are different heights, so I've extruded them at a different time. This is the top, by the way, and here's the bottom. You can see that I've used the same base to do the bottom and the top. And here's the actual printed result. So the sketch extrusion method, it's great for technical drawing. You do it in, you can do it to precise dimensions. It's easy, easy to manipulate in 2 dimensions. Again, like I said, you don't have to measure in 3 dimensions when you have 3-dimensional objects to get them relative to each other. You only have to measure in 2. So that's a whole other measurement that you don't have to do, right? It's nice.
Just a thought. How do you know your board will fit in the case unless you, in the design?
Measurements. You set up calipers and you measure it, and it is very precise.
Because I've always made a 3-dimensional model and fit it inside the case.
Yes, that's the hard way to do it, I can guarantee you. I initially started out trying to do it that way until I found this sketch extrusion, and now this is the only thing I do. So get yourself a nice set of calipers, measure it, and then there's a couple other things that I can show you. You need to put in hairspray, some wiggle room to make sure that it fits nicely. And we can get into that a little bit later. So for me, it's mostly easier to think in 2 dimensions, right? I say it's mostly easier because it is 2 dimensions. You don't have to worry about the 3rd, but you do have this other thing that you have to think about is how it extrudes and how I'm going to get the volume, get to that 3rd dimension. So it's mostly easier, but it does add one more thing that you have to think about. But again, I find it easier. So it's not good for complex 3D shapes. You can't do these big overhangs and big curved structures, and you don't want to redesign Venus de Milo in this method because you just can't extrude that. That's impossible. You can't do that. It's not going to work.
Unless you cut it in half, print it in 2 parts, and then
Certain capacity.
I'm just thinking.
Maybe you design it layer by layer, each layer, and then you stack it back up.
Yeah, there we go.
That's done. So it is a 2-step process. You draw all the necessary shapes in 2 dimensions, and then you extrude it into the 3rd dimension. So it's distinctly different from those. So just like we had some canned three-dimensional shape, we have some canned two-dimensional shapes, right? We have a square, a circle, a multi-sided polygon. Then you have some irregular shapes down over here. Just random, you can do lines. Over here are so there's two different tiers. You get this poly line, which is just a straight line. And then you have this, basically a curved line where you put multiple different lines. That's what this is here. It's a spline. So you do a spline where you start here and you put it here and it curves around and you can do these custom random shapes. Here's another curve. It's just an arc, so it's a much more regular type curve. And then over here you can do this is another arc that you can do. So you drew in 2 dimensions, now you extrude it into the 3rd dimension. So these are the same shapes that I just showed you before. You basically have your multi-sided polygon here, and you just lift it up into that 3rd dimension. That's really all it is. So the cylinder here, it's the same thing, same as the cylinder before, except it started as a circle. I raised it into that 3rd dimension, and now it's a cylinder. Over here is my regular shape that I drew. One thing to note is obviously it has to connect. Otherwise, you can't extrude it with where the open part of it is. So you just extrude that guy up into that dimension. You can see over here I didn't do those because it didn't end up connecting. To note that here, once you highlight on an actual object, the extrude is going here. So here's a simple extrusion that I'm going to show you. I just drew a rectangle, and then I used one of the tools up here to do an offset. And basically, offset is just take every line in half and make it bigger, right? So I just made one rectangle, and then around it I drew another rectangle, and then around that I drew a 3rd. And that's really all I did. So I still have, so I just have 3 rectangles here, and I actually did, now that I'm looking at it, I did 3 rectangles just because I'm so used to drawing 3. Because what happens is, this inside rectangle is actually what I use as airspace around a PCB. So if you put a PCB in there, you don't want the walls of the box, which you'll see that this turns into, to be right on top of the PCB. You need extra space. So I just must have audited this and just designed it. But you can see here when I extruded it, I selected the inside and the one on the outside, one in the middle, and I extruded that up. And this is in millimeters here, so I extruded it up 5 millimeters. And that's going to act as the base of the box. So next I selected this outside rectangle, and then I extruded that up 20 millimeters, and you can see now I have a base, and I have the walls of the box, and now, as you see, I got a box, right? What's that?
Your bottom's too thin, it's flat, you have to extrude it and take this down.
It's there, it's just the way that's the way that you see it on there. It is actually the same from the previous slide. Cool. So a little bit more details on the extrusion. When you're designing in 2 dimensions, try to draw all the features of the 3-dimensional object into one base, one base drawing. You can see from the previous couple slides, I drew both the top features and the bottom features of the entire box. All on one drawing, just so I can use that same one. So I extrude the top, and in the negative direction, I extrude the bottom in the positive direction, and it comes together and becomes a box. So it's very difficult, it's somewhat difficult, it takes a little bit of time, but if you really think about it, if you look at this box, and if you were to squash it down into 2 dimensions, and you think about all the individual components of what you have on there, That's what your end goal is, to try to design and try to do. That's why I say in my previous slide it's mostly easier to think in 2 dimensions, because it is that thinking of all the features and all the things that you would want to possibly extrude and putting it into that 2-dimensional drawing. You know, don't worry about it if you don't actually get it, you know, a feature that you were looking for, but you can always put it back in there and do the extrusion without any problems. So I generally just try to do it all. It's not a definitive you have to do it all, but it does turn out much better when you do all the features all together. So remember to add this airspace or wiggle room. The printer does get very precise, but there are some unexpected things that you get out of a printer like this. The dimensions are very fine, but if you actually take a look at this cube that I printed out, you can see that the corners are very sharp. And if you actually run your finger across them, you'll find that at the very corner, it actually comes up a little bit and it makes the point a little bit sharper, so the sides are going to be tighter than the actual point. The actual outside dimensions will be correct, but the side dimensions might be a little bit slightly smaller, right? So it may not be 100% flush on the side. And that's just due to the way that the printer runs, and right? So it runs up to the corner, it stops for a second and continues on while the material is still coming out at the same speed. And so basically it stops, you get a little bit more material at the corner, and then it continues on in the other direction. So that's why you get a little bit different shape than what you're actually expecting. It's very easy to avoid. Just make it a little bit bigger. These calipers go to the thousandth place of measurements. That's just way too much for this printer, right? I mean, the thousandths of an inch. Yes, it does print at 10 microns, but real world things that fit into boxes are not at thousandths of a millimeter. The other thing to remember is that when you do an extrusion into an object that currently exists, it will subtract that extrusion from what's already extruded. Now that's not a downside, that's a feature. You can use that to your advantage, and I'll show you on the next couple slides where you can actually make holes in boxes using that method, and that's the way you do it. Is you take a design and you extrude it into another solid object, and it will subtract that object from that extrusion from that object. Remember, when you're using 123D design, make sure that when you do your extrusions, you rejoin all your objects back together before you export them. Otherwise, you're going to get just one extrusion. In the previous slide, I did 2 different extrusions. I did the bottom and the sides. If I didn't rejoin them together using the join, if I exported, I would just get the sides, or I would just get the bottom. So make sure you join them back together.
Do you want to tell them like what watertight means? Like,
yes. You're talking about manifold type.
Whatever they always call watertight.
Yes. Yeah, watertight. Yeah, it's basically meaning that it's all together, that nothing is floating up in the air, and basically because you can't print in the middle of the air, it has to be on the paper. That is the one big advantage of doing 2-dimensional design, is that you always get the manifold, you always get the watertight design. Unless you do some crazy stuff, you're going to get something that's more likely to be printable than if you do that 3-dimensional design. So then also, I put this in here. I hope to say it throughout this presentation. Is share your designs. Throw it out on the Thingiverse. Let other people enjoy your work. Right? It's an open source environment. That it's a coming and going thing, right? You go out on the Thingiverse and you get stuff, but then you also need to contribute back to it. So sketching on solids. This is what I was talking about, that I was going to show you about how the subtractive process. This is actually quite a difficult slide to see. What the first thing that you're going to do is what I've selected up here is a circle tool. And the one thing it's going to ask you, the very first question that 123D Design is going to ask you is, what plane do you want to draw this circle on? And in the two-dimensional space, normally your plane is just a flat surface, right? You want to draw a circle on a flat surface, and that's my plane, is that first surface. And actually, when you do your, when you're doing all your two-dimensional design, anytime, it's kind of annoying because every time you select any tool, like a line or a square or a circle, it's still going to ask you that first question: what plane do you want to draw the circle on? And for the first part, it's always going to be the base. Well, in this case, I've actually selected the plane is this vertical surface of the outside of the box. It's kind of difficult to see. It's these lines that are showing it, but it's basically the outside edge of this vertical plane here. So now that I've selected my plane, I can actually draw a circle on that plane. And again, this is dimensions. This is a two-dimensional circle. And now I'm extruding this circle into the third dimension. And like I said, it's a feature when you extrude an object into an already existing object, it subtracts that object from it. You can see over here I got a hollow circle. That's what I want. Again, you can do any shape that you want. You can actually tweak it and modify this extrusion at the time. You can do it at an angle. You can do it in the up direction. You can make it different size on this end versus this end. So there's all sorts of things that you can do. So now I'm going to show you a more advanced extrusion method. This is something else that I designed for myself, along with this box. This is a temperature and humidity sensor. I went and bought a kit that I need to measure temperature and humidity. So I went and bought a kit, I assembled it myself, and then I needed to print a case for it, right? So here's it all assembled, it's working, and here's the box that I printed it. So here's my base sketch. With the box, what you can see, some of the features here is, here's the corner post that I'm going to use to screw the top and bottom together. The outside dimension you can see, and here's my little, my hair space, the wiggle room in between. This square in the center here, that's the window of the box. You can see I have big 8-segment displays, and I need this window so that I can actually see them. A couple other features, there's a reset button here. This kit has a nice feature that it will, this is a light sensor, and it will dim the 8-segment displays such that it's not blinding you and making you look at it, which is nice. And then one other feature that's kind of hard to understand is this is where the humidity sensor is right here, temperature and humidity sensor here. And so what I thought was I want to build a partition wall around this sensor here such that it separates it from all the electronics because they might get warm and may affect the humidity sensor. So I figured I would draw a dividing box around it. You can kind of see the But that's what this here is. This is the dividing wall that's later going to be extruded such that it builds that wall. Around here you can see that here's my reset button. You need two circles because you need the outer wall of the cylinder that I'm going to extrude and the inner wall. And you can see here. I have screw holes up here for screws, and then down here these are going to be holes where wires come in. I have one here for power and one here for the serial interface to the device. Down here you can see that I kind of just went out into the much farther out into the box. doesn't matter. I'm not going to really extrude this area up here, but I actually found that it's easier if you make them much bigger, so that you can actually select these features much easier. And over here, I didn't do it so much. Maybe I'll learn how to do this one. It's going to be much bigger. But that's one thing that you'll get used to once you start doing more of these. So now I need to start extruding. I'm going to extrude the bottom here. So first, I'm going to do the base. The base just starts out with this whole area at the bottom. This is going to be the bottom surface of the box. So I don't need to select some of these other things, right? This was for the window on the top. I don't need to worry about that. This is for the top. I don't need to worry about those. All these at the top. So I'm just really just going to do this whole outside space, including the air space, because I want that to be flat on the surface of the system. One thing to note is that I don't select the features down here where this open hole is, because I'm going to later extrude those to a different height. So the other thing to note is that you can only extrude something once, because of the nice feature that when you extrude into an already existing object, it makes it go away. So basically, you get one chance to extrude it. If you want to extrude it again, it's going to go away. But then you can extrude it again, and it will be a different height. So if you mess up, you have to do that process. Delete it, re-extrude it to the right height. So here's kind of a screenshot. I'm trying to back off of it so you can see. This is a very thin layer. Here, I think I only extruded it to 0.5 millimeter, which is pretty tight. Doesn't waste material. It actually works great on the printer at 0.5 millimeter. So I kind of try to show that from here. The next step that I'm going to do is now I'm going to extrude the outside edges of the box. So what I'm going to do is I'm selecting all of these, the stubs, and leaving out the circles because that's where the screws are going to be. They're going to end up being holes in the box, right? You don't want to fill your screw holes. So I'm selecting all these individual components, just holding down the control key and then selecting multiple things here. And here I extruded it. I extruded it up so you can see all the features of the box. Now it's starting to look like an actual box and not just another lines on the page. Your holes for your screws, that will be later in. And still these holes here that we haven't extruded, these are going to be, again, these are holes in the walls of the box for different components. Now I extruded here, I took this picture because I extruded these up just a little bit because my board is not actually 100% flat on the bottom where the components come in. They actually stick up just a little bit off the box, and that's where the power comes in. So this shot just shows that I've extruded this hole, and they're actually different heights, and so you extrude them at different times. So now that I've done the base, now I'm going to do the top. I use the same two-dimensional drawing that I used before. It's convenient. It's already all done. It's great. So now I'm going to extrude. So now I need these features, right? So I don't need the window. I don't need these guys because I'm going to do those in the next extrusion. I don't need the sides because they're going to be done. This feature here, I don't need those. So one thing to note here is that I extrude it in the negative direction. It's kind of hard to see, but that's negative 0.5 millimeters. And if you think about it, what you're doing while you're doing it in the negative is because you're doing so you did the bottom, that goes up, and you're going to do the top, that goes down. So you can extrude it in negative, a negative dimension over it. So what happens is I'm going to extrude everything negative, and then I'm going to flip it over so that I can do the print. And it actually shows screenshots of that. But what this does when you extrude it in the negative is that you don't have to worry about, do I have to mirror this? Do I have to flip it over when I do this? Which selection do I do? And it's like, you don't have to worry about that. It's all there, all in the right dimensions, just extruded in the negative. It's not a problem. And you can see here, Now I did my little partition wall for my temperature and humidity. I extruded that negative 0.75, and it goes in the downward direction. Negative 0.75 and negative 7.5 or something like that. Goes in the down direction, and so here's my reset hole and my power hole. I kind of zoomed in so you can see. This is down to negative 0.5, and this is down different dimensions, so I did those separately. And the final two would be this partition wall. Basically, this fills most of the hole because where it actually comes out, it's just an 8-pin that sticks out. So I don't need most of the hole, so I fill it up with this extrusion. And so now what I'm going to do is I'm going to move this up. So I've extruded in the negative direction, so I'm going to move it up on the build platform to the maximum height that I've extruded it. So I extruded something, it's also changed from millimeters to half inch because that's already a half inch that I've extruded here. But basically I'm going to move it in the Z direction, in the up direction for this next step, which is I'm going to rotate it 180 degrees so now that it's sitting on the build platform. And it's much better to do it extruding into the negative and then flip it over so you don't have to worry about it. Because otherwise I would have had to extrude this on this side and you're looking at it and you're like, well, that's opposite of it. And then I have to look at it like this and then this doesn't make sense to me how I do that. So extrude everything negative, raise it up and then flip it over. Much easier. So now a couple other things that I'm going to show you. These are some of the other tools that are available in 123 Design. These are smart primitives. You can see that you can get text. Here I've done two different things, right? So I have three-dimensional text that's laid out here, and then I did another three-dimensional text, and I lowered it down into this solid, and I subtracted it. So it's very quick and easy to modify here. And some of these smart primitives are pretty advanced. Here you can see some gears. These are specifically 10-degree gears. There's all sorts of different other gears that are available. These guys are updating constantly. People are putting all sorts of these smart primitives. The reason why they're called smart primitives is because they scale in the right way such that you can make them bigger and smaller, right? If you just made this gear bigger, the teeth wouldn't necessarily match if you expanded another one because the teeth of the gear don't expand in the same ways that the center of the gear expand. So these smart primitives are smart because when you make them bigger in dimensions, it redraws them in a logical format such that they do fit back together.
Can you use 123D to make smart primitives or no?
No, you can't. Basically, there is free tools. There are free tools out there that can make smart primitives, but 123D Design is not one of them. You can use them, but you can't make them. So the way that they're doing these smart primitives is they're using like OpenSCAD. That's another free product out there. It's a very math-based programming language that does all of that scaling all built in. Because it's quite intricate and detailed things that you have to think about when you're actually scaling like gears and things like that, or threads on a screw, all sorts of different things. OpenSCAD is pretty cool. I've used it, but it is not for the faint of heart. You definitely have to be a programmer.
Yeah, as a non-artist, when I first saw OpenSCAD, I'm like, oh god, this looks great. It's writing code.
Yes,
like functions and stuff.
It is a coding. You're coding, programming, but the one very challenging thing about it is you're coding in 3 dimensions. You're coding objects in 3 dimensions. It's not for the faint of heart. I am a programmer at heart, and I can do 3D design, and I find it very difficult to think about how things rotate in three-dimensional space, and it's very challenging. But if you're up for the challenge, you should download it. It's free. There's lots of examples, and it's open source. So here's another one of the smart primitives. I just threw it on there just so you can see. Like I said, these are constantly updating all the time. This is some kind of rhino beetle. It's pretty nice looking. But it actually, one of the cool things is it breaks out all the parts for you. So if you actually wanted to print all the individual pieces and parts, you can pull those onto the table and then export them however you want, and then you can print the individual objects.
Because the scale though, you can make a giant version of it and turn it into a mech and ride it around.
Yes. Yes. And actually, funny you say that. It's they actually just 3ders.org actually had a link recently to how long it would take to use a MakerBot 2 to print your house. And it turns out it's about 220 years. And surprisingly, it's only about, it was a little over $200,000 in material.
The wood infill.
Actually, they didn't give the details. I think they got the wow factor when they said 220 years. So basically what they did is, they did it in bricks, right? They said, how long does it take to print a brick? How many bricks would it take to build a house? And that's how they got to their numbers.
I'm going to build a plastic house.
So the one thing that I wanted to point out is, so once you've designed something, now what do you do with it, right? If you don't own a printer, you're actually very well off, right? There's lots of things you can do with your design. You can go out and think a version, you can share it. You can go out on Shapeways and you can buy it. You can buy and sell objects, right? You can design, make your own design. You can go out on the Shapeways and publish it and say how much you want to charge for it. And that's all you do. People go out and they say, oh, I want that, and they actually send you money because they use your design, and Shapeways actually prints it out for the user in whatever material they actually want to print it in. Maybe they want PLA, maybe they want gold or titanium. Shapeways can do all that. And all you do is you get royalties from the design. You say, I want $15 anytime they design this or make it. You get $15. Shapeways charges from making all that, so you get your cut. You can also get it made by Make XYZ. This is something that I've had recent success with. I've had several orders. Basically, it's just an open forum. I go out and register my MakerBot on Make XYZ, and someone has a design that they want printed. They go out and search by zip code, and they find a local printer or a printer that charges the right amount. I charge 25 cents per cubic centimeter. They upload their STL. Make XYZ sends it to me and says, hey, is this acceptable as something that you're willing to take on? And I say yes. It automatically sends an invoice back to the customer. They accept the invoice. I print it out and I either ship it or give it to them, and I make money off of it, and they get the part that they want. It's very nice system. The one thing that I can say is that there's several of these that are popping up, and there's more popping up of these printing services that are popping up. There's more of them popping up every day. And I think the lifetime of this type of service is going to get pretty limited. Because right now what you're driving off of is the availability and price of printers, right? I paid over $2,000 for this guy. Maybe you guys can't afford $2,000, so you can send it to me and I can print it for you, but this is not going to stay $2,000 for very long. This guy is going to be, I would predict in the next 3 to 4 years, this same printer will be at least $1,000, if not cheaper than that. So go out here to 3D printing price check. This is a list of all printing services, and then you can put in basically you put in how many cubic centimeters your object is, and you can get the cheapest guy in the material that you want it in. And then you can just basically compare the price of how much it's actually going to cost. So basically, in summary, 3D printing is the new thing, right? President Obama mentioned it in the last presidential address. That's how big this has gotten this fast, is that you have someone like him doing this. And this is great. I mean, it's great for the open community. It's great for us as hackers and builders. We can think of it. We can print it out. We can make these things happen that quick. Instant gratification is what I have on my blog. Instant three-dimensional gratification.
After 6 hours.
Sometimes after 6 hours, sometimes after 5 hours, or sometimes after 30 minutes, and then it fails to print, and then you have to reprint it, and then you go back, and then you're frustrated, and you're like, why is this not printing? And then you go back, and then you finally get it, and then it comes out, and it's a three-dimensional object. You're like, wow, that's great.
Gratification.
Yes. And then you think about it, and you're like, wow, that's happy, and you put your Raspberry Pi in it, and you forget about it forever. But the one thing to note is that watch for the continued rapid changes. This technology is very new. We are actually not even close to the height of how rapid this technology is changing. It's going to be changing even faster at a faster pace for the next year or so before it starts to level out and the rapid change slows down a little bit before it levels out and becomes stable. That's a good thing and that's a bad thing, right? It is changing very fast. Systems are becoming more capable, but it's also a bad thing because they are changing very fast. You buy a printer today and it becomes obsolete tomorrow. It is that fast of change. The other thing to note is that on the same breath, of course, 3D printing is rapidly becoming practical, right? It wasn't, but just a few years ago, 3D printing is not new. 3D printers have been around surprisingly for 15 to 20 years. It's been in the high-end manufacturing era where they cost $50,000 to $100,000. And it's just recently that, with all these technology progress, that you can get something like this for $2,000. I can buy it from the store, I can set it on my desk, I can hit the print button, and something comes out. That's the first time that this has ever happened, in the last 1 to 2 years. So the other thing is that design is quick and easy. I mean, you saw what I designed here. Those are very practical items. They didn't take long to design. They didn't take long to actually print out of the printer. So it's very easy. It's very quick. It's well within the range of what us hobbyists can do. We can go out and buy these. We couldn't previously go buy a $100,000 machine. It just didn't work like that. I don't have any to work on that. So that's the thing. The technology of the 3D design is progressing to match the actual three-dimensional 3D printer. So it is keeping pace. The software is keeping pace with the hardware out there. That's a very huge feat for the software design, is that it can